developer platforms, right? That's something that most companies that I know of have been working on for a while now or are about to start, right? The idea is relatively simple. You want to create a developer platform or a platform, internal platform in your company so that everybody can be self-sufficient, right? So that everybody in your company has certain expertise doing certain things, and you want to enable those people to do other things without spending 75 years learning those things. Like if you're a Node.js developer, your application needs a database. You have two options. One is send email to Joe and wait for a couple of days or weeks or something like that. Or the other option is to have an internal platform where somebody goes there and executes a command or clicks a button or whatever and gets a database without really knowing how databases work in depth, because Joe created database as a service, right? Joe converted his or her experience into a service that can be consumed by everybody in your company. Relatively straightforward. It's not straightforward, it's not easy to do it, but easy to understand why we want it, right? Now, most of the internal platforms I've seen are failing on a couple of important aspects. And the first one is that most companies fail to understand that we've been building platforms for a couple of decades now, and we know how to do it, right? And when I say we know how to do it, is you look at AWS, you look at Azure, you look at Google, you look at Datadog, you look at any public platform, and they're all following the same pattern. And that pattern is very simple to explain. That pattern is you create a service that does something, right? Service for managing database, or service for managing applications, or service for managing pub subs, or whatever you want. And the second part is expose that service through an API, right? Absolutely every public platform works like that, right? You might go to the AWS console and think that they actually built a console, but they didn't. They built an API, and console talks to that API, Terraform talks to that API, anything talks to that API. Very simple. Another problem that many people face is that they simply don't do those things. They think that, okay, I have a bunch of random stuff in my company, and all I have to do to create an internal platform is to put Backstage on top of that, right? And I'm going to, everybody familiar with Backstage? Tough crowd? Oh, cool, okay. So I'm going to develop stuff in Backstage that will somehow glue all those things together. I don't know, Ansible, Terraform, GitHub Actions, what's or not, instead of going back to the basics. Again, couple of decades old, create a service, expose it through the API. And the important note here is that tools like Backstage or Port and a few others, they're not platforms. They're just one of the potentially many user interfaces somebody will have to talk to your platform. And how do they talk to your platform? Through API. In theory. In practice, you don't want to know. Now, so that's what we are going to go through today, right? If you would approach developing platform in the same way as most companies are doing, you would start probably with something like this. This is a Backstage configuration. Somewhere, here we go. Sorry, this is not the Backstage configuration. This is, my bad. This is Kubernetes custom resource definition. And Kubernetes is very important in this story. And it's important because it's the most widely used API today. And this will offend many of you, probably. But that's basically what most of us are doing today to generate two things: controllers and custom resource definitions, right? Controllers are those services running somewhere, waiting to do something, whatever that something is. And custom resource definitions are basically ways how we create new API endpoints in Kubernetes, right? And this is one example, right? And here you can see, oh, okay, so if you want to, what is this? Create a cluster through my service, you can define version and you can define size of the nodes and how many nodes you want and which namespaces you want and so on and so forth, right? You define this as YAML, you apply it to Kubernetes cluster, and all of a sudden you have a new endpoint, and anybody can create a new resource or delete or update or do anything they want, in this case with databases, right? Behind that API, there is a controller that does the heavy lifting, kind of checking, oh, okay, so what's the difference? What should I do, what I shouldn't do, and so on and so forth. It's an application at the end of the day that monitors events that are recorded by communicating with API and a few other things. Now, what most people do is do something like this. And this is Backstage component, if I'm not mistaken. Yes, this is a Backstage template, and then people would spend enormous amount of time defining it, right? And that's a complete waste of time. And the reason is very simple. If you look at, I did not spend much time on the previous one, but if you look at it, oh, you can define version, you can define node size, you can define minimum number of nodes, you can define namespaces, right? When you want to create a cluster, for example. And this is exactly the same what exists in the API already, right? Backstage completely got it wrong. It assumes that you're going to define things in its own format, and that no other format exists, right? And then you would do the same thing in Terraform, and then you would do the same thing in Ansible, and you would redefine the same thing all over again because every tool simply wants a different format of exactly the same thing. Because this is exactly, if you ignore the format, exactly the same as what I showed before. The alternative to that is to say, okay, I'm not going to define in Backstage or whichever portal I'm using anything, or anything that already exists. Instead, I'm going to assume that there is an API. In my case, that's a Kubernetes API. And I'm going to discover what can be done through that API. I'm going to make that web UI as dumb as possible. No logic, no calculation, nothing, or almost nothing, except go over there, figure out what are all the things that you can do, and paint it on a screen. If you find schema with 7 fields, then just create 7 fields on a screen and let people populate those fields and let them click a button, create, right? Completely dynamic, no need to repeat yourself because, again, APIs are discoverable. So then, let me actually show you how that looks like first in Kubernetes, right? If I list APIs, those are all the API endpoints I have in my Kubernetes cluster, right? I can create whatever this is, instance. Let me make it smaller. There we go. Parameter groups in AWS. I can create issue labels in GitHub repositories. I can create users for my storage and so on and so forth, right? Those are probably a couple of hundred, 300-400 APIs that do the things that I need them to do, right? Now, if I would give this to an average developer, they would freak out completely. Kind of, what do you mean? If I want a database in AWS, what do I need to do? I need to create RDS and a subnet and a VPC, an internet gateway, and 57 other things that nobody understands except, again, Joe. So we're going to skip that. And I'm going to show you 2 specific APIs that matter in this demo today. And that's this one, apps and SQLs. Basically, I extended my own Kubernetes cluster. I'm using Crossplane. And you can do it in 57 different ways. And created API endpoints called applications and SQL databases. And anybody who wants to create an application or a SQL database can just create an instance of that resource. Right? You will see the schema of that in a... Actually, let me show you the schema right now, right? And this is, again, that repetition I was saying, telling about, right? If any tool in the world, including Backstage or Port or whatever you might be using, wants to find out, okay, what can I do with that thing? Just go and check the schema. And schema tells you everything. Like, hey, you can define an array of list of databases in that database server. Cool. You can define a list of schemas in that database server. Cool. You can define some secrets. Cool, right? You can set the size of that database to be small, medium, or large. It's a schema like anything else. It's an API. No need to repeat yourself anywhere else. And that's what we are going to do right now. I'm going to use port. Tell me if this is too small. And if you're familiar with port, cool, fewer. It's like Backstage, but better, but not free. That would be the definition of port, right? And in port, you can do the same things I showed you in Backstage. You can spend endless days and hours defining all the things that you might need or you might not need. It already exists elsewhere. We're going to skip all that, because the folks at Port, I was yelling at them for a couple of months, and then they finally did this. And this is, go to my cluster and find out what can be done. And now, if my demo does not fail, and most of the time it does, we'll see. It will appear, maybe. Let me see, port. Logs, does it work? Token, I knew it. I knew it. I knew it. How do I fix it? Okay. You're gonna see live fixing on stage right now. Port. Oh, this is too small for me to see. Cool, 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 cool. There we go. Port helm something something crossplane, not crossplane. No, I don't want that one. Hey, here we go. Here we go. Let me install it again. Let's see whether it works. Helm uninstall port namespace port something, right? Port what is it? Port Kubernetes exporter Kates exporter. There we go. What did I call it? Port Kates exporter. There we go. Let's install it again. See whether it works. I forgot. This is about not being free. You need client ID and client secret and all this stuff. Port logs. Let's see. Does it work? Okay. Let's see. Let's see. Look at that. There we go. Everything can be fixed. So it went to my cluster and said, what can I do with your cluster? And it auto-detected that, hey, you can create an application. You can create a SQL database. In a real world, I would have probably many more. I would have backend application, front-end application. I would have, I don't know, queues, pub subs, whatever people need, right? And you can update those and you can delete those, right? Now, what it did really is that it auto-generated all those fields based on the schema, right? Not all of them are useful to people, so let's enable a few. Let's say databases. We should make them visible. Visible true. And what else? Name is always visible. And let's say composition ref name, we should make it visible as well, right? You choose which fields you want to show, and then one more thing. This is the only thing that it cannot get from the schema, and I don't remember by heart, but I know that I have it written somewhere. Where is it? Yes. This is my repo. There we go. The only thing that it doesn't know from the schema is that whenever whenever it creates something, there are two options. It can apply directly to the cluster, right? It can create the database. Now, I'm not sure how familiar you are with Kubernetes, but in my organization, if you do that, you're automatically fired. There is no review, there is nothing. You're fired immediately, right? what we do is that we push stuff to Git and then use GitOps tools like Argo CD or Flux, synchronize it in a cluster so we know what you did, why you did it, and then we can fire you for just reasons instead of random reasons, right? So I'm going to say, okay, whenever somebody creates something, push it to this organization. This is the repository. And what was the, I forgot the file, GitOps YAML, there we go. And use the GitOps YAML GitHub Actions that will do the trick, right? That they will modify the file and push it to Git. And then users just come and say, okay, I want to create a database. Cool. What can I do here? I can, what was it, the name? I forgot it somewhere. Let's say I want it in AWS. Okay, I want in AWS, right? This is my implementation of the controller of the process that can create database anywhere in AWS or whatever. I want to call it my DB in Stockholm, and the namespace, let's say A-team, and I want it to be large because I'm rich. And then it will execute it, and if my demo does not fail, it will eventually have it in Git, and we can double check. GitHub, github.com, that was paradox. There we go. Let's see whether it worked. 6 hours ago, last commit, it did not work. Maybe a few seconds ago, let's see. It's running right now. Give it a time, give it a time, give it a time. Let's see. Now, look at that. It created a commit, it pushed the file there, and now, if I go to my cluster, what was the namespace I said? A-team. Team get SQLs. Okay. Eventually. Eventually it will get there. Give it a minute. And then we'll see it work. Let's see. While that is happening, while that is might be working or not, let me explain you how all this happened, right? So, we have port, which is, does this work? Yeah, it does. Look at it. We have port, which is just a dumb UI. Doesn't do anything, right? We have Kubernetes cluster that has an API. And that API can be extended to do anything you want in the whole wide world, right? And I expanded it myself with a bunch of things I can do in AWS, a bunch of things I can do in Azure, a bunch of things I can do in Google. But more importantly, I extended it with that new two endpoints that are API applications and SQL databases. I did it with Crossplane because Crossplane creates that controller that will manage stuff. I have a GitHub repo because if you don't have a GitHub repo, then I don't know what to do with you. And Argo CD that synchronizes things. So the whole process really is that port goes to Kubernetes and finds out, what can I do? What are the things I can do? I can create applications and SQL databases. Cool. Let me create automatically the form with all the fields and all the options and what's not, right? Crossplane created those CRDs. Crossplane extended APIs with those two additional endpoints. And those endpoints, and then user goes, like me, to port and say, I want a database, or whatever I want, whatever somebody prepared for me. Port sends it to Git, because it's illegal to do it directly in a cluster. Argo CD finds out that there is a difference between what you want and what it is, right? That's basically what it does. The difference between the desired state and the actual state, and it puts it into the cluster. And then cluster creates stuff. In this case, since I said I want the database in AWS, it will create RDS and what's not. If it worked, and we're going to check it out right now. Yes, it did. It created my database in Stockholm custom resource. And if you look at behind the scenes, Kubernetes controller expanded it. That simple definition, those 5 fields were converted in route table associations, route tables and security group, and security group rule, and security group, and subnet, and VPC, and bunch of stuff that nobody understands because nobody cares, right? Except people who are dedicated to work in AWS. And eventually, this will end up being, let's see whether it's happening right now. After a while, I will have all those things created and managed in AWS. And all I did was really nothing, just enable self-service in whichever UI you are using. I already showed you I showed you that. I can show you Argo CD. Everybody knows Argo CD, I mean, right? You would be too shy to say no. Yes, okay, I will assume you do. Anyways, it's synchronized. It got from Git repository to my cluster. It's working with the AWS right now, and it's creating database for me. And that's my gist of the talk. Any questions?